This video is going to cover the two reactions of benzene called nitration and sulfonation. So first let's look at nitration. So nitration is where we're going to take our benzene and nitrate it, or add a nitro group. The reagents that are needed here are nitric acid, which is HNO3, and sulfuric acid, H2SO4. And what is actually added to the ring, like I said, is that nitro group, which is an NO2 group. Whenever we're doing these, it's good to know what the structure of these groups actually looks like in case it can bring in more resonant structures. The nitro group looks like this, to where you have an oxygen with a negative charge, nitrogen has a positive charge, and the other oxygen is neutral. So there's a lot of lone pairs, pi electrons that can be used as part of resonance here. That will be more useful in later sections, but it's good to know what those groups actually look like. So let's look at the mechanism for nitration. So the first step is we need to get a nitro group from this nitric acid. So nitric acid looks like this. And throw in some lone pairs here. The sulfuric acid gives us a proton to work with. And what's going to happen is we're going to protonate the nitric acid, which seems strange to add a proton to an acid, but what's going to happen is it's going to give us a good leaving group here. We're going to have water as a leaving group. So now one of the lone pairs from the negative oxygen kicks down, and we're going to kick water off. And what we form, so we form water, H2O. We also form the NO2 group, which does have a positive charge. That is now our electrophile. So we can have our benzene, which is our nucleophile, come in and attack. That's going to, at the same time, kick a lone pair back up into the oxygen. We like to remember we've got the two hydrogens here as well. So we're going to form our sigma complex. Now, again, full mechanism would show the resonant structures of that sigma complex. We've seen that several times in previous videos, so I'm not going to take up the space to do it here. Water is now what's going to come in and deprotonate. We are in acidic conditions, so that will happen. Those electrons will kick down to reform our benzene, and now we have the nitro group attached to our benzene ring for the nitration reaction. This is going to be more useful in later sections, but just bring it up because there is a direct connection. We can take this nitrated benzene and do a reduction and convert that into an amine. Now, this is the only way that you can do the addition of an amine to a benzene ring, is you have to go through the nitration product first, and you can't directly add an amine. And the reagents to do this, you need iron in acid, and then a second step of water. And we will talk more about these a little bit later, but this is a common reaction used in industry if you need a amino group on a benzene ring. Next, we're going to look briefly at sulfonation, mostly just the reagents. So sulfonation, we're going to add the SO3 group to the benzene ring. And the reagents needed to do this are what we call fuming sulfuric acid. Actually, I guess there's only one M in fuming. And what this stands for is concentrated sulfuric acid. But that is very important because this reaction is reversible, and the reversible conditions are actually dilute acid. So if you were to take that sulfonated benzene, mix it with dilute sulfuric acid, it will revert back to just benzene. This is going to be very useful later when we're trying to do multiple additions to our benzene ring, because that sulfol group can be added as what we call a protecting group. It can be placed in there to block a spot so that something else doesn't add in that spot and then later removed. So keep that in mind.